Yes, good morning, dear students. Welcome for the physics class. So today we are going to discuss the further parts of motion in a plane, right? Motion in a plane chapter. Okay. Right. So in the previous class we have studied some of the laws for addition of a vector, such as the triangular law of vector addition, and the second one is parallelogram law of vector addition. Those two are very important from the point of your examination, annual examination. They may be asked for 2 or 3 marks. Okay. So next we are having one more concept, that is the subtraction of a vector. Subtraction of vector. Okay. Right. Let me consider two vectors, vector A and vector B. So here I am going to subtract vector B from A, that is vector A minus B. Then how can be it defined? Right? So here subtraction of vector B subtraction of vector B from vector A is defined as addition of vector minus B to vector A. Right? I hope you understand. So here subtraction of vector B from vector A is nothing but addition of minus of vector B to the vector A. How? So that is, so vector A minus B. It is a subtraction of vector B from A. And here we can write it in another way, like vector A plus of minus vector B. So just have made some adjustment in a vector A and B. If I write vector A plus of minus vector B, that is nothing but vector A minus B only. You can take this minus outside. Plus into minus is minus. So again we are going to write vector A minus B only. So by writing in this manner, we are not going to change any value of vector A minus B. Is it clear? So I just rearrange some of the signs here. So here the subtraction of B from A is nothing but addition of minus B to A, and I'll write the upcoming vector as a resultant vector, vector R. Resultant vector R. So here minus B, minus vector B is nothing but a negative vector of vector B. Minus B is a negative vector of vector B. So already we have studied the meaning of a negative vector. What do you mean by the negative vector? So here, the negative vector, the magnitude of the vector will be same as that of the initial vector, but the direction is opposite to the direction of initial vector. So let me consider this as a diagrammatically. So that is, so look here, I am going to write a vector A in this direction. Now, vector B I consider, which is subtracted from the vector A in this manner. Look here. It is vector B. Okay. So vector A and vector B I have considered. Right? So now I have to subtract vector B from A, like vector A minus B. And we have written as A plus of minus vector B. So here minus B is nothing but the negative vector of the B. Okay. So which has the same magnitude as that of B, but the direction is opposite. So our vector B is in this direction, then which is the direction of the minus B? So that will be opposite direction, right? In this manner. Okay. So here the magnitude of B and minus B are same, but the direction is opposite. Okay. So here we have a vector B, and in the opposite direction I need to consider its negative vector, that is a minus vector B. Okay. Now just look here. This is the vector A and this is minus vector B. So here can I apply the triangular law of factorization? Yes, I can apply, because here look, minus B and vector A are of the same order. Here the tail of minus B is coincide with the head of vector A, right? So these two are of the same order. So here I will apply the triangular law of vector addition. So that is the another side of the triangle in the opposite order represents the resultant vector of these two. That is vector R. I hope you understand. Okay. So this is about the subtraction of a vector. This is about the subtraction of a vector. You just take a screenshot and write it in your notes. And next one, for a motion in a plane, we have certain vector concepts. For a motion in a plane, we have some vector concepts, such as position vector. So here position vector is used to represent the position of the object with respect to origin, and a displacement vector, and a velocity vector, acceleration vector. These are some of the vector concepts which we are going to study in the for the motion which is in the plane. Okay. So for motion in the plane, we have some vector concepts. Among that, I will first take into the consideration of for the position vector. Position vector usually represented with the help of R, small letter R. Okay, vector, small letter R. Right? So look here. So I will consider the xy plane, the plane which is lying in the xy coordinates. So it is x-axis and this one is the y-axis, right? So it is nothing but the origin. So our object or our particle is somewhere at this point. Okay. So let us consider this position as a P. And with respect to this position, the coordinates I am going to consider as a x comma y. X comma y. Okay. X comma y. Right? So here P is the position of the object with the coordinates x and y. Okay. Let P be the position of an object with coordinates x comma y, right? Then the position of vector is given by. How to represent the position vector? So here the position vector is used to represent the position of the particle with respect to the origin, right? So now I draw a line from origin to point P. So here this is the vector R which represents the position of the particle. So that is called as position vector. So already in previous classes we have studied that if any vector is lying in the xy plane, it will be resolved into the two components. So one is along x direction and another one is along y direction. So for that we have considered like look here we have already considered like it is a vector A. Then when we resolve it along the x direction, so this will be the x component of vector A. I'll take it as AXI cap. I think you have remembered, okay? And this one is the y component of what? The vector A. So that we have considered as a ay j cap. So here ax is nothing but an x component of A, and ay is nothing but an x component of y component of vector A. Like that, here instead of A we have taken the vector R, means the position vector R. Is it clear? So then we have the resolution of this position vector R along x and y direction. So then, how do I need to consider them? Right? So it is what? The R x I cap. And it is what? The R y j cap. But here I will consider simply x I cap and y j cap. Instead of considering rx I cap and ry j cap, I'll just consider x I cap and y j cap. Right? So that is x I cap. So what it means? It is the component of vector R along x direction. And here y j cap. Okay. What it means? It is the component of vector R along direction of y, or along y axis. Here. So this is what is the position vector R, vector R. So now look here. Then the position vector R is given by so look here, vector R is equal to x I cap plus y j cap. How I have taken this one? So as we have studied already in the magnitude and direction of a vector. Magnitude and direction of a vector concept we have studied. Vector A is equal to ax I cap plus ay j cap. Right? I hope you remember this one. So here instead of ax, so x is x component of A. So I have considered x component of R. What is the x component of R? That is x into I. And what is the y component of R? That is y into j cap. Is it clear? Okay. So where x I cap is the component of vector R along x axis. Okay. Then one more, that is y j cap. That is what? The component of R along y axis. Component of vector R along y axis. Is it clear? Okay. Then, if you want to speak about only the magnitude of position vector R, then the magnitude of vector R is given by, so here I will just write R. So because we want to calculate only the magnitude, so I won't write any vector involved, means arrow mark on the head of R. So because here we are calculating the magnitude. So then how I need to calculate the magnitude? As you have to know. So vector A, magnitude of vector A, calculated as ax square plus ay square, right? So already we have done that one. According to that one, here what is the x component of R? That is x square. I will consider I cap. here because I cap is used to indicate the direction. So we don't want direction here. So I'll just manipulate the I cap and explain. And what is the y component? That is y square. Is it clear? Now, next comes. So just now we have taken the magnitude of our position vector. The next, how to find out the direction of position vector. So let me come back to the diagram. If look here, if theta is the angle made between the vector r and its x component. If theta is the angle made between the vector r and its x component, then, okay, look here, if theta is the angle made between the position vector r and its component along x direction, that is xi cap, then the direction of vector r is given by, here, that is tan theta is equal to, you consider tan theta, then opposite, what is the value of opposite? It is equal to 1, right? So that is y divided by adjacent means, that is x, right? This one is x. That is why theta is equal to tan inverse of y divided by x. Here, okay? So from knowing the value of theta, we can find out the direction of the position of the object with respect to the origin of its plane. Is it clear? Okay, take a screenshot and write it in your notes. Okay, next second one is displacement vector. Displacement vector, right? So here, now to derive the displacement vector, just consider xy plane. In that xy plane, I will consider an object which is moving in a curved path. Curved path means like this. Okay. So let me consider initially a particle will be at this position, that is P1, and here the corresponding value of x and y are x1 and y1. Okay. And finally the object has been moved here. Okay. So this is nothing but the position 2, that is P2, with its coordinate value x2 and y2. Okay. The now, as you can look here, the position of vector of the particle when it is at P1, I'll write it as R1, vector R1, position vector R1, okay. And next, the position vector of the particle when it is at position P2, that is vector R2, vector R2, right? So R1 is the position vector at P1, and the components of R1 are x1 and y1 along x-axis and y-axis respectively. Like that, R2 is nothing but it is the position vector of a particle at P2 with its components along x and y-axis are x2 and y2 respectively. Now, here, how can we denote the displacement vector? So look here, the particle has been displaced from P1 to P2, then the shortest distance between them is what? The displacement vector. The displacement vector. And I will write this displacement vector as a delta R vector. Delta R vector. Here. Okay. Now the time to revolve R1 and R2 along the x and y axis. So as you can see here, I consider this as the component of R1 along x axis, and I will name it as x1 I cap. X1 I cap is the origin. And here, it is what? The y1 j cap means the component of vector R1 along y axis. Similarly, so here I consider the component of R2 along x axis, that is x2 I cap, and the component of R2, the component of R2 along y axis, that is y2 j cap. Right? So now delta R is the displacement vector of a particle from P1 to P2. Then here the displacement corresponds to both x axis and y axis. If the particle is displaced in the xy plane means the displacement is regards x axis as well as y axis also. That means the displacement is going to happen both along x and y direction. And what is the amount of displacement along the x axis? That is here we can say x2 minus x1. That is the displacement along x axis. So I will just consider that as a delta x. Okay? Delta x. And the displacement is along x axis. And what will be the displacement along y axis? That I will consider as a delta y. That is y2 minus y1. Is it clear? So whatever things I have explained now, I'm just writing in terms of a word. Consider a particle moving in a curved path, moving in a curved path. Okay. Let P1 be the position of particle at time t1. Initial time I consider t1. Okay. Similarly, t2 is the position of particle at time t2. Right? The next step, vector R1 is the position vector of a particle where at P1 with its component x1 y1 similarly R2 is nothing but position vector at P2 at P2. This is components x2 comma y2 x2 comma y2. Then the displacement in the time interval t2 minus t1. Initially the time is t1, the particle is here, and the time is t2, then the particle is at p2. So now during the interval t2 minus t1, the displacement, how can we write the displacement? Then the displacement of particle during the interval I'll just take delta t is equal to t2 minus t1 is given by delta r is equal to r2 vector r2 minus vector r1. Okay, so here delta r vector is equal to r2. How can we write r2? As we have written a as a ax I cap plus ay j cap. In the previous case, r has been written as a x I cap plus y j cap. So here r2 means x2 I cap plus y2 j cap is the way we can write r2 minus r1 means x1 I cap plus y1 j cap. And just arrange the coordinates of I at one side and the coordinates of j one side, or the components of j one side. So that implies delta r vector is equal to, look here, x2 minus x1. x2 I cap minus x1 I cap. So we are having an I cap on both sides, so I'll take it as a common. x2 minus x1 I cap plus y2 minus y1 j cap. So look here, x2 minus x1, can I write it as a delta x? So already here I have denoted, okay? So that is nothing but a displacement along x-axis. Delta x I cap plus delta y j cap. This is the displacement vector. It includes both magnitude and direction. If you want only the magnitude, then magnitude of the displacement is given by, so that is delta r is equal to under root, as we have written in the case of vector a, which is equal to under root ax square plus ay square, like that. Here also ax, what is the x component of displacement? That is delta x. Delta x square plus delta y square. This is how we can calculate the magnitude of displacement. I hope you understand, okay? So just take a screenshot and copy it in your notes. Just take a screenshot.